Hello everyone. Today we are going to use R-Instat to investigate a conjecture which states that after 1, the Liouville function, that is Ln, is never positive. Let's see. Open your R-Instat. This will pop out. Click on New Data Frame. When you click on the new data frame, it will prompt you to input the number of columns and the number of rows that you want. This will depend on the data set that you want to work on. For my case, I just need one column and 1,000 rows. Then click on OK. This will generate a column named X1. Let's rename this to something nice. So right click on that column, select rename column. So the current name is X1. Let's have the new name as number. Then click on OK. Great. Now let's generate a new column that will give us the prime factor decomposition of the numbers in the number column. To do that, click on prepare, select column calculator. Under the basic, we have a drop-down arrow, select integer. We want to use the integer keyboard and narrow down to the factorize to button. When you click on the factorize to button, we have this expression generated, but we want to generate for which specific column? The number column. So under the variable, select number, then add. So we can name this as prime factor decomposition. So you can use this try button here just to have a preview of the numbers, or just click OK to generate your column. Great. So let's expand this column. Good. So we have our new column for the prime factor decomposition. So 1 is just 1, 2 is just 2, 3 is just 3, 4 is 2 times 2, we have 6, 2 times 3, we have 8, 2 by 2 by 2, and so on. Now, let's generate a new column that will capture the length of each row for the prime factor decomposition column. To do that, click on prepare, select column calculator. So before you execute or perform any function or operation, make sure this expression box section is blank. So use this clear button to do that. We want to generate the length column. This time, we are using the list keyboard. So when you click on this drop down, select on list, then select length. We want to generate the length for the prime factor decomposition column. So under the variable, select prime factor decomposition, then click add. So we can name this column as length. Once you've done that, click OK. Great. Let's investigate the length column. So the length of 1 is just 1, the length of 2 is just 1, the length of 2 and 2 is 2, the length of 2, 2, 2 is 3, and so on. So we want to generate a new column that will capture the type section. So the type section is either odd or even. For this case, we are not referring to even numbers which are divisible by 2. We are referring even if the number of factors are divisible by 2. Number of factors, get the difference. It's even because that number is not divisible by 2. It's even because the number of factors are divisible by 2. So let's generate a new column named type. To do that, click on Prepare, select Column Calculator. So this time you're going to use, make sure the expression box is blank by using this button. So we are going to use the logical and symbols keyboard. Click on logical and symbols keyboard. So under the logical and symbols keyboard, we are going to use this button if else so that we can input our command, like what exactly do we want this specific column to generate. So click on if else, then select the specific column that you want to work on. We want to work on the length column. So under the variable section, select length, then click add. So what do we want the if else button to do? So if the length is divisible by 2, we want it to provide even. Otherwise, if the length is not divisible by 2, it should generate odd. So to do this, use the mod operator here, the modulus operator. So click on modulus, and we want if the length divisible by 2, so 2, comma. For this if else button, the first one to generate is always false, the second is true. So if this expression is false, let it state odd. And if the expression is true, let it state even. So once you do that, we can name this column as type. Then click OK. So again, let's investigate this type column. The length of this is 1. 1 is not divisible by 2, so that is odd. We have this 4, the length is 2. 2 is divisible by 2, so that is even. 8. 8 has the length 3. The factors have the length 3. 3 is not divisible by 2, so it's odd, and so on. Great. Let's now generate a new column to capture the Liouville function so that when that number is odd, we have it allocated -1. And if that number is even, we have that allocated as 1. Let's do that. Click on Prepare, select Column Calculator, make sure the expression box is blank. We are still using the logical and symbols calculator or mod. Select if else. So we want to investigate. If it's even, you allocate that 1. If it's odd, allocate it as -1. So let's select the length column, click add. So use the modulus operator to do that, so that if the length is divisible by 2, this indicates that that is even. So if it's false, let it indicate -1. But if it's true, it's truly divisible by 2, that is even, let it indicate as 1. So we can name this column as Liouville. Again, you can use this try button to have a preview, or let's just click on OK and see what happens. Great. This is very true. We said if that type is odd, indicate -1 or allocate -1. If it's even, allocate 1. So in real life, an odd number has a -1 Liouville function, and an even number has 1 as the Liouville function. From the conjecture, we have to find the cumulative sum of these Liouville values. To do that, click on Prepare, select Column Calculator. Make sure this expression section is blank by using this clear button. So to get the cumulative sum of the Liouville column, we are going to use the transform keyboard. So use the drop down, select transform, yes, then select the cumulative sum button. So the cumulative sum button is this one. So click on cumulative sum, and we want to get the cumulative sum of the Liouville column. Click on Liouville and add. Once you do that, let's name this column as cumulative sum. Sorry, don't have we are not supposed to have any spacing there. So cumulative sum Liouville. Great. Let's click on OK. Good. So let's expand this column again. Good. So you'll realize that all these, after the first one, all these are all negative. All these are negative. All these are negative. So our conjecture, which stated that after 1, the Liouville function is never positive, the cumulative sum is true, as shown here. Thank you.